Last month we were talking about, I noticed in coming to these things that it's pretty heavy on the ops, and there seems to be less of a dev influence in this group. So just by a show of hands, who has a dev background? All right, looks like we're at least half today. All right, continuous delivery brought in the devs. All right, so what I want to do is mostly not talk, but have fun with some code. So we'll talk about principles because I'm from the architecture group and that's what we do. We always start with the principles, and also it was in the flyer that we have to talk about the book a little bit. So the principles come from the continuous delivery book by Jez Humble. So who's read that one? Most of the dev hands. So I think that book's 10 years old now, but actually I only read it a couple of years ago, and it kind of changed the direction of how my team operates. And so we've kind of made it our mission since our team read that book to implement continuous delivery correctly. We thought we were doing it before, but wasn't even close. So anyway, what we're going to do today is talk a little bit about principles, and then we're going to get out the editor, we're going to get out the command line, and we're going to start from nothing. And we're going to build a REST API in Node.js. Anybody familiar with Node? Any of the operations guys familiar with Node.js? Operations guys had to deploy Node.js applications. How about Docker? Any Docker guys in the room, or ladies? Cool. So what we're going to do is we're going to take nothing and make a REST API out of it, and we're going to kind of build it up through the stages of a continuous delivery pipeline. We're going to fall short once we actually get to the end of the pipeline where we actually deploy and test and shut things down. Didn't have time to get all that, and I don't think we'll get through it all anyway. But the principles are all going to be there. And finally, we'll take our just regular Node application, put it in a container, and we'll deploy it via Helm to a Kubernetes cluster sitting out on GKE. So hopefully it's going to be a lot of fun. All right, we talked a little bit about continuous delivery book. I think if you read the first chapter, you get the gist of it. The rest is just details. It's definitely worth reading the whole thing, but you can get a lot of mileage out of just the first chapter. And so I promised you principles. So I'm going to pull them off of this piece of paper here because I'll forget them otherwise. He lists a principle. His first principle that he lists in there is really the goal, and I think it's the goal of continuous delivery. And I'll quote it here. It is create a repeatable, reliable process for releasing software. And that falls kind of right smack dab in the middle of DevOps proper, right? So continuous delivery is about, starting from the developer, going all the way to release. Now DevOps goes a little further into actually operating the thing. So I'm going to stop there. I'll let the ops guys talk about that later. We're all DevOps here, but we have specialties, right? All right, some of the main principles. Everything in source control. Start with that, right? Everything in source control, not just the application. Database scripts, deployment scripts, all your testing scripts, right? It's all code. Your infrastructure is code now, right? That should all be in source control. There's arguments about whether it all goes into the same repository. We could argue about that later if you guys want. The other one, let's see. Automate everything. Actually, the book says almost everything. You need a little bit of manual testing here and there for look and feel, things like that. Right, but everything else gets automated. We'll be doing a lot of automation here tonight. Let's see, bring the pain forward. If it hurts, do it more often, right? If something is really painful, it causes you a lot of trouble, you don't want to do it, right? And then you let it fester and it gets worse and worse. And then by the time you actually come around to having to do it, it's even more painful. So the more often you do a thing, especially with automation, actually, the more often you do it, the more likely you are to automate it and it becomes less painful. Build quality in, right? Testing isn't a phase, it's everybody's job. Quality assurance is not just for the QA guy or gal, right? QA is everybody's responsibility. Here's an interesting one. Done means released. There's a lot of depth there. Doesn't necessarily have to mean released to production, but a dev can't say, hey, I'm done, I checked in my code. It has to be released somewhere. It has to be deployed. We have to know that the process works all the way across and it has actually been tested against some real looking data. So we get two more. everybody is responsible for the delivery process. That's the whole idea of shift left, right? You got all these dependencies on your infrastructure team and your QA and security who doesn't even get involved until you're trying to deploy, and right, everything's upside down. Move all that stuff. By shifting left, that means do it early. Figure it out in the beginning. Finally, continuous improvement. I think continuous improvement is part of a lot of things. You know, it's part of the agile ideas. It's part of DevOps in general, and continuous delivery just sits in the middle of that. So always look for ways to improve. Those are our principles. As we walk through the steps of building this application, we'll kind of refer back to these principles to keep in mind of why we're doing those steps. Now the other icon here is GitLab. Has anybody used GitLab before? Quite the crowd. All right, so what it is, it's a Git host. That's about this much of what it does. If you use it, you'll find that you're really familiar with it if you've used GitHub. Apologies to Chip, there's a lot of copy paste going on, I think, at least in the ideas. But it does a lot more, right? There's issue tracking, and we'll actually use that tonight as well. But the thing that drew us to it was the CI/CD capability. So how nice is it that not only is your infrastructure code, is your application code, or your data code, your tester code, now your deployment pipeline is code. All right, I think everybody's moving this direction, but hopefully you'll see how easy it is when we get into this. Have some fun with the pipeline as code. Now, they want to be all the things. So like I said, they do issue tracking. If you pay enough, they do all kinds of security testing and things like that. They want to be the entire pipeline, the entire tool chain. So one tool instead of a chain of many tools. And I find it pleasant to work in. So that's as much of a sales pitch as I'm giving because I'm not the sales guy. I'm showing you what I do. All right, this is my last slide, and this is where we're going to start. Blank slate. All right, now for the fun stuff. I can find my mouse. All right. Speaking of GitLab, this is a board. So doing a little issue management. So I spent a good part of last night figuring out exactly how this demo was going to go. And I decided to make it not just a demo, but something not necessarily interactive, but something that you could do at home later. So I put a lot of time into defining these tasks. And I happen to be a big fan of Markdown. And Markdown and code go really well together. So here we go. Our first task is to create a Node.js application from scratch. How many have ever done that before? All right. Of the ones who haven't, do you want to see that, or do you want to just start with one and we'll go start doing some continuous delivery? You know what? It doesn't take long. Let's go build it. All right. Step one. Let's create our directory. So I'm sitting here, and where am I? So source Gibbles. I've got a Gibbles group in my GitLab account. So I create a folder or a directory to hold all of the projects that are in that same group. So you'll see I've done a little pre-work here to make sure everything works nicely. So I'll do a load demo. Okay. Now, all right. So I've already got all of my dependencies, right? I've got Node.js installed. I've got Docker and Helm, all the pieces that I need, which you would also have to do this stuff. So nothing up my sleeve, right? Got an empty directory. Let's just npm init. So this will start up a brand new application, asks us a few questions. I hate starting with 1.0. I gave some instructions on what to do. A musical tribute to entry point. I'm going to put this in a bit of a hierarchy. So I'm going to make this source app server.js. Test command, we'll leave that for later. Git repository, leave it for later. Don't care about keywords. Sure. License, don't care. All right, so it's going to create a package JSON for me. It's kind of the definition file for a node application. Sure, I'll take that one. All right, there's my package JSON file. All right, now let's see our instructions. So our application is going to have two dependencies, Express and Bunion. Express is just a web framework. Bunion is a logging utility. So now that I'm here, I'll do an npm install Express and Bunion, and I'll tell it to save those to my package JSON so that if you pull it down later, then you can get those dependencies directly without having to ask me what dependencies are in this thing. All right, once we've done that, then we can start creating the code. Actually, let's create the directory structure. That's interesting. I saw this earlier. I looked it up and it said some kind of network error. So this could get really interesting. Do alive. Fortunately, I have a backup. Did it? Guess I could go off of there it went. There it went. Turn that off. All right. So weird. All right. So now we have our dependencies, and we'll do minus p. Does anybody know what the minus p does? Makes it so that I don't have to go in and create the source directory and then create the app directory, right? And then create the lib directory. I can create the path all the way down. It'll create the whole thing for me. Actually, you know what? It's time to fire up the editor. How many of you guys use Visual Studio Code? I'm a huge fan. Maybe even a fanboy. Mainly it's because of that. All right. So let's go back to our instructions. And I'll put all the code in here for you. So you just copy and paste it. It's easier with a real mouse. Or not. On my server file. Okay. So if I go into app folder, create a file, paste in the code. All right. I don't think we need to review all this code, but I'll give you a quick idea of what it's doing. It's like a ridge there. Every time I click the thing, it moves over. Come on, you can do it. All right. It's a pretty simple web application. We're pulling in those two dependencies that we installed. We're pulling in the module that we're about to copy in and create a new file of. It just holds the data that the application is going to use. We're not hooking up any actual database or anything. This sets up logging, and then we set up some routes. Okay, so if you just go to the site without anything after the slash, you get the standard hello message. Anybody know who Kernighan is? Let's hear it. What's he famous for? Anybody know what else he's famous for? He was part Orange Shell. He also wrote the first Hello World program. So this is an homage to Professor Kernighan, who is a professor at Princeton now. Okay, so now we have a songs resource, which in standard REST fashion will give you the list of songs, and that's basically what our data file is. And then you can specify that you want it to return a single song by giving it the ID. Super basic stuff. And then we also have one more resource that's a health resource, and we'll get to this way later when we're doing the Kubernetes deployment. where that thing will ping our health resource to make sure that it's still alive, and so it can hook up the services correctly and kill it if it's dead, or kill the pod if it's not responding. Okay, that's the basics of the program. So now we'll create data.js. We'll pull in the data. We'll see if you guys can find a pattern in this data. It's going pretty fast. Unless you've got it locally, you probably won't be able to see the pattern. All right, and then we have one more, and I don't remember the file name. Incrementtest. It's going to be a very useless library that I'm only using because nothing else was unit testable. So when we write unit tests, we're gonna test this library that nothing is calling. All right. So there's our application. Do I think it'll work the first try? Anybody have a little faith? Oh, look in there. You would have been wrong. Yeah, it's wrong. There we go. All right, so it's running now. If I want to go curl it, say curl localhost 3000, and I'll pipe it to Bunyan. Oh, that one didn't even matter. It must be going really slow to give me that meter response, because it doesn't usually pop up if it's fast. And let's try this. Something a little better than interesting. All right, anybody see it yet? Actually, all right, so now we have an application. Step 1 complete. Right, it's all working. What am I looking for? There it is. All right, so it works. So let us mark this guy as finished. All right, and we'll go back to our board. We'll pick the next story, or the next task, really. All right, we're not in source control. We're freaking cavemen here. Okay. Let's start with some gitignore files. Does everybody know what gitignore does? Does anybody not use Git that would admit it? All right. I won't give you a hard time. I don't want him anymore. All right, so at the root, we'll create our gitignore. This is a lot easier with 2 monitors and a wide keyboard and a mouse. All right, there we go. And we will create also. All right, who's familiar with Git attributes? Anyone? Anybody know what Git attributes does? It makes it so that Windows and Linux and Mac developers can live together happily. Except that the Windows guys are all just jealous. And I'm one of them. What this does is we're establishing that .js files and .sh files will have line feed endings. We're doing it for the sh files because we're calling those shell scripts. We're going to run them in Docker containers, and they're not really happy if they have character return line feed at the end. JavaScript is more forgiving, but in a minute we're going to add a linter, and it's very unforgiving. And line endings are one of the things that it cares about. So we'll nip that in the bud right now. And then we have those two files, and I think one of the most important files in a repository. Anybody? And normally my readmes are nice and fat, but for now we'll just do really simple, just because we can. All right, it's still running here. Now, what's our next step? Now we actually need a Git repository. So we're going to say Git init. Hey, now we have Git. We can do Git status. We'll add all the things. Cool, not cool. I don't care. All right. So I did all this on my Ubuntu box at home. So it's treating me a little different on Windows. So we get add our origin, get remote, add origin. Does that look right? That looks right. Anybody know what the next step is? Oh. Did I not commit? I didn't commit, did I? Yeah, they're staged. Git commit. Initial commit. There we go. Now git push u master origin. No, origin master. Set up stream. So it maps them together. All right. Another story done. And now we have joined the Stone Age. We'll call that done. And if we go look now, there's actual code. Pretty sweet. All right. What's next? I want my board. So if you notice, I've got these open issues over here. These are things that I haven't done yet. Things I'm not ready to show you how to do yet. So we're not going to talk about those. All right, linting. Every programmer's favorite activity. All right. Somebody want to talk about what a linter does? Besides make people cry? It enforces standards on the code, and it can get really picky, especially with JavaScript. There's a book that came out a long time ago called JavaScript, the Good Parts or something like that. And there's linters that won't let you use anything but the good parts. And there's linters that enforce that you put the semicolons in the right place and all your spacing is even and correct, and you have a line at the end of the file so GitHub or GitLab don't bitch at you every time you push a file up and it gives you that little nag at the bottom that says you don't have a line at the end. So we're gonna install a linter here. So we're gonna use ESLint. So let's do npm install ESLint save dev. So before we did save, and that saved Bunyan and Express as kind of our runtime dependencies. Every other dependency we add from here to the end is going to be a dev dependency, which means we only need it during the pipeline, right? And so when we package our application for final release, we don't want all those extra dependencies. That just adds bulk to our container. So we'll say save dev on this guy. Hopefully it'll work. Need the Jeopardy music. All right, here we go. All right, so now. So if I try to run ESLint right now, it's not going to work, unless it will because I have it installed globally. Fail. But if you don't have it installed globally, and you've only installed a package locally, you can use the npx utility, and it'll dig into the node modules folder, which is where all that crap that it just downloaded is sitting. And there's a .bin folder that has your executables in there. So if you say npx ESLint init, then it's gonna ask us, just like we did with npm init, it's gonna ask us how we want to lint our code. And I want to go full Monty. And sure, that's fine. Nope, we're not doing that. Does your project use TypeScript? Nope, not at this time, sir. Where does it run? Not in the browser. Yes, in Node. I wanted somebody to tell me. Use a popular style guide, Airbnb. I like YAML files. I didn't used to, but they've kind of grown on me. Would you like to install? Well, yes, thank you. All right, now we wait again. This was faster on the other side of the building and also at home. What's that? Oh, really? It makes it, it can do things, it'll download things if they're not there. Okay. So now we have a linter. You guys want to see what happens if we run it? Oh, you know what? Let's get fancy. Let's, wait, what did I do there? Let's add a script. Why am I looking at the working tree? Oh, because I've got Git open. So ignore that test script there. So the packages folder or packages file is kind of nice because you can hide little scripts in there. And scripts that you run from here, if you say npm run in the script name, it will do like npx does, and it'll dig into your node modules folder and find executables for you. So if I say lint here, I can just say ESLint source. I think that's how you do it. All right. Anybody want to take bets on how my code is? So that's a problem with npm. Let's say silent. It doesn't give me the extra npm error crap. Now, all that is just coming from my linter. But you can see it's all pretty much the same error because I created all these files on Windows. So if I come in here, let's fix these real quick. Make it line feed. Now, if you went to pull these down and you already had the get attributes file set, then when you pulled it down for the first time, it would set that for you. But because I created it with a line feed. And then Git kind of manages line endings going in and out, but Git hasn't really had it yet for me. So I'll change them myself. Let's try that again. So it really bitches at you when it's mad, and if it's happy with you, it just doesn't say anything. No compliment whatsoever. You just get a 0 return code. All right, we're linting. And that's it for that story. So what we want to do now is, I showed you that I can do the command line, but what I really prefer to do when I build my commits especially using Visual Studio Code, is I go in to the little Git tab, and it's not like the full featured, like full windowed Git manager. This helps you build your commits. And what I really like about it is that it will show me the diff right here, and so I can stage my changes, and I can build 2 or 3 different commits just by looking at my changes. So let's see. Yeah, we'll just stage all this. But if we look at these modified files, package lock isn't a good one to look at. We'll see that we added our script. This is green because there's a new comma at the end. And we have these new dev dependencies, right? So I can go look. That's line. All these are just line endings. So when I add these, look, those will disappear because Git doesn't care about line endings. All right, so we'll say add linting commit and push. Some people might give me a hard time for not doing those on the command line. I know how. I prefer to do it this way. So now, if we go back here, this story is done. Told you not to mess me up, man. We'll try to get that on the next one. I can even have it close the ticket. Remind me on the next commit. All right, what am I doing here? I'm looking at the board. So we're just picking these off one at a time. Why did that not clear? Oh, that's interesting. There we go. All right, now we've got a linter, now we need a pipeline. So now we're going to use GitLab for more than just storing our code. So actually, I haven't been talking about the principles. Each one of these steps comes with principles. Oh, damn it. Oh, damn it. Now that's in the audio twice. Okay. So for these, I assigned the principles of automate almost everything, and if it hurts, do it more often. So that kind of applies to pipelines in general. So we're going to build us a new pipeline. And I'll just copy this in, and we'll talk about it once I get it over there. The GitLab file has a very specific name. It's .gitlab-ci.yml, not YAML, just YAML. I don't know who got that wrong. Was it everybody else, or was it Kubernetes? I don't know. Okay, so here's our first pipeline. This is a very minimal pipeline. Our pipeline has one stage, it's the build stage. Our build stage has one job, it's the build job, okay? So obviously this is stages, and then everything else that's a kind of a top level property defines a job. There are special circumstances where you can put a dot in front of something and it becomes nothing. So every job defines a stage. That's what stage it belongs to. It makes more sense if there's more than one. This right here tells it where I want my job to run. So I have a Kubernetes cluster running in GKE, and I have the GitLab runner running on the Kubernetes cluster. So instead of using GitLab's shared runners, which are a little slow, I'm using my own Kubernetes runner, and it's much faster, and it's in my, meaning Google's, purview. Okay, so tag just tells it where to run. If I took tags out, it would actually run on the shared runner that GitLab hosts. Next is image, and that's the Docker image that my code will run in. Okay, so the GitLab runner will spin up a pod. It will pull down the Node 10 Alpine image, and it'll stick my code in there and kick it off. Yes, it comes from Docker Hub by default. You can specify other places if you want. Now, before script and script is really just one thing, but it's a nice break to show kind of preparatory things versus what your actual script is. And so whenever I run this job, so I have Alpine Linux here. So Node installed on Alpine. If you've messed around with Docker, you hear Alpine a lot because it's a really small image. And small is good when you're doing all these distributed things and you're doing really fast commits. So you don't want to pull the whole image down all the time. Pull a very large image down all the time. So what we're doing is APK is the package manager for Alpine, kind of like APT or what's the other one, Yum. So this is just the package manager for Alpine. And so we're going to add two modules, Python and make. Make because, actually in this case, make and Python both, because something in the npm in the dependencies of our program, they want to do some kind of build in there after install or something, and they choke if they don't have those things. We'll use make for ourselves in a couple of steps. So what happens is now we have a clean container, and it throws our script in there that installs the things we need, and it throws our script in there, and it says, hey, okay, npm install. By the way, it also pulled down my Git repository. So I did a Git pull. And so in that local, just like we're sitting local and running npm install and Git pull and whatever, it does that in the container, runs npm install, gets all my dependencies down, and then it says npm run lint, runs the linter. And that's all this is going to do for now. It's not super fancy, but we've automated a quality assurance check. All right. So it pulls your code down and puts you in the root of your code. Like your current directory is just like I'm sitting in the root of the code, like in my hello demo. It's got a hello demo on that image, and its current directory is just like mine, is hello demo. And so it will execute these statements from that place. Does that make sense? All right. Was that all the story wanted me to do? I just need to push it? Oh wait, what's my ID? Chip, where's the ID? I've never used it before. Where do you see it? Okay. All right, here we go. Add a new pipeline. Closes number 3. Want them apples. So we can actually go here to CSED, look at pipelines. Oh, did I push? Nothing's happening. There we go. All right, our first pipeline. Will it blend? And we have to wait for npm install again. I think they have faster interwebs in the Google Cloud. There we go. It worked. It's a miracle. All right, so what do we have now? We have a working program that has proved that the code is nice and clean. That's about it. All right, but that's a start. We have a pipeline. Well, let's see if our story moved. Look at that. All right, now for a really fun step. Let's put some testing in the mix. All right, our principles for unit test: build quality in. That's going to be any test that you automate. The principle is build quality in, and also automate everything, almost everything. Okay, now to do unit testing, guess what? We need some more dependencies. So we'll come down here. We'll say npm install mocha. If I can spell it. Chai and moke awesome. We'll say those are dev dependencies. Okay, so Mocha is the unit test framework. There's a million of them for every language. Chai is the assertion framework, so you can do kind of BDD style or assert style. There's several different styles. And then Moke Awesome is a reporter. So Mocha kind of really componentizes everything. And so reporters are pluggable. I can have a Mocha reporter that, as it's running the tests, it will show an airplane flying across a landing strip. It'll do the Nyan cat with a rainbow behind him. It'll do various forms of XML or JSON or whatever. But this one is actually going to produce us a website or some static HTML anyway. Okay. So tests are kind of special in that they break a few rules that we don't want the rest of the code to get away with. And so I'm going to create a new ESLint RC YAML in the tests folder, which I don't have yet. So if I do a make dir source tests, do -p, source tests unit. And if we go into tests, we can create a .eslint rc.yaml file. Put this junk in there, and this tells the linter that, hey, when you're in this directory, we're using all the globals that are exposed by Mocha, so don't complain about that, all right? And then there's some like testy type things that you do that break other rules that we don't want to do elsewhere, and so we put those things in there. While the rest of the code has to deal with the full brunt force of Airbnb base. Okay. So there's that. And now we want to change our test script, which currently just complains at us. Right? We can say npm test. So npm has a few special scripts that you don't have to say run for. Test is one. There's also a start and maybe another one. Yeah, so it did exactly what we thought it would do. It just griped at us because that's what we told it to do. So now we're going to say, hey, we want to run Mocha against the unit tests. If there's folders, if there's directories underneath unit, I want you to dig down into those as well. And I want you to use moke awesome for your reporter. And now if I say npm test, it will do nothing because I have no tests. So did I miss a step? Oh, I did. But in the early hours of the morning, I was doing links to snippets instead of doing everything in line. So it became tedious. So this is going to be incrementtest. So in my unit test folder, I'll create incrementor-test.js. Go down. So you'll see that the editor is griping at me with these little red squiggles. I don't know if you can see them. I think that's a shortcoming of code, as much as I hate to admit it, because I installed ESLint after code started, so it couldn't get all the right dependencies in place for itself. So if we close this and opened it back up, it would be happy again, and we might do that in a minute. Okay, so moke awesome ran, and it showed us on the command line the output of our tests, and it said it created a JSON report and an HTML report, and lo and behold, there they are. And if we actually go there and browse to that thing, please tell me I have that installed. No, there it is. Oh, view in browser, damn it. Fine. There, you get a nice HTML output, okay? In a future step, we'll actually put this up in GitLab and have GitLab host it for us. So that if you're going back and looking at your test and reviewing, you can actually look at it in this method instead of trying to parse it out of the big command line output. Okay. Oh, I don't want you. All right, so now we want to actually test in our pipeline. What was 6? Oh, yep. Good idea. I would notice that when I came here. Yeah. Okay, git ignore. Yeah, guys, pay attention and keep me honest. I pulled an all-nighter, so mine's are a little blurry. Okay. Now it should see all that turned red, and now I only have a few files because I updated my git ignore. What that means is that it ignores it. So if I do a git add dot, it doesn't pull those files in. Well, if I try to add them explicitly, will it let me? If I say git add mokeawesome/index or whatever. Force. Okay. I'll take your word on that. Okay, so add it to the pipeline. Here we go. Bam. Testing is added to the pipeline. Corey, what's our story number? So see how before we do this, I go through and I look to see what I did. The JSON log file doesn't matter. It's auto-generated. That's a new file, and that's a new file. So I will say closes. So it actually shouldn't close it until the pipeline passes. Let's trust but verify. So we will look at the board. Still there? Shit. Sure, I'm glad I'm recording this. To play for all of GameStop. All right, let's try again. Oh, fail. Okay, I would like to amend my statement. It doesn't move it until your merge request is merged. If you're using merge requests, we'll do that later. Yeah, you just put the ticket and it'll link it. I was trying to do the magic, man. All right, so let's go see our pipeline. Boom, done. So you see, if we ran those scripts locally, we would get this exact same output locally. And that's one of the things we really try to push with our guys here, our folks here, not just guys, is your scripts should run on your laptop exactly the same as they run on the CI server. If they can't do that, then you're doing something wrong. You're going to have a problem. So all these scripts run exactly the same, get the exact same output. Mm-hmm. Mm-hmm. Right. There is a way to run a GitLab runner on your own laptop. I don't know if that's overkill. Honestly, though, once we get to the end of this and we're actually doing it all in a container locally, then it'll be done on the container locally and on the container on the CI tool. So it will be the same. Yeah. But for what we're doing now, you're right. You're absolutely right. It's actually slightly different because it's just running raw, right, on my laptop, and then it's running in whatever environment that I choose with that image tag. Good call. Anybody getting lost? Anybody think this is going way too slow besides me? All right, makefile. Does anybody know actually when make came around? Like, it's been building C programs for decades. I'll take your word for it. I don't know. I was hoping somebody else did. It's been around a long time. We're not using make the way make was intended to be used. So we've started using make. We actually saw it on quite a few open source projects, and it's a really handy kind of automation shortcut tool. So you don't necessarily have to write a script for everything. You can just put a rule in your makefile and put your little piece of script in there. It does have some quirks. One thing is that it disagrees with what the rest of the world has already decided, and that it likes tabs, not spaces. 76. I was actually born. Okay. Anyway, makefile is a great, make is a great tool. The makefile is just the definition of rules. They are hierarchical, so you can have a rule defined. For example, here we have a lint rule and a test rule, right? If I wanted to, I could say that lint depends on test. And so if I say make lint, it will go run test, and then it will run lint. And that came from, I don't want to give too much of a history lesson here, that came from back in the day when people used make as it was intended, where you actually put file names as the rules, and the code underneath was actually building the binaries. And so you have the C command, the CC or whatever command to build the object files, and then the final executable that's the output of your linker has all those object files as its dependencies. So if I want to make my main program, it'll go dig down and build all the objects and then link them all together and give me the file. We put phony at the top of this to tell it these aren't files, just do your dependency logic and execute the thing and don't worry about it. Another thing is the @ sign that you see at the beginning there just means don't print this statement, just run it. Another thing that you might notice is that we kind of have kind of multiple layers of scripting going on here, right? So we have the package.json file that has this lint script and the test script. And now we also have it in a make file. So I can say npm run test, and I can say make test. It kind of feels redundant, and it kind of is at this stage, but we're going to put a lot more crap in that make file, and then your fingers will just want to type make all the things, and your fingers actually won't be able to type npm without your head really getting involved. So it just makes sense to put these things into make. I'm not saying that you have to do it that way. That's the way I like it. And this is my show today. All right, so let's make our make file. All right, make file. It can actually be spelled with an upper or a lowercase m. I prefer uppercase. So that's it. That's the whole make file. So now I can just type make lint. Oh, look at that. I'm glad we ran that because we have new files, right? Which file was that? Oh, my test, of course. Didn't have this problem on Ubuntu. So now I say make lint. And it's happy. Make test. All's right with the world. Okay, all we did was add a make file. We didn't add any new functionality. So now we want to go change our pipeline to use make also. Lint. You know what else we can do since we have the make file? Oh, we already did. We have the little silent thing there that says, hey, if it actually fails, don't give me all the npm puke that comes out. Okay, I think that's all we need to do for this story. We are number 5. Let's see if I can remember to push it this time. File. We'll just put number 5 in there. Okay, so now we can kind of code review ourselves before we actually push, before we even build the commit, right? So yep, that's the only changes we made there. Add it to staging. Brand new file, fine. And that's also a brand new file. Boom. See, I know how to do it. Right. Let's go watch it run. Actually, you can see in our pipeline history, well, it's kind of a weird average. It's a 10-second range so far. We'll see what this one comes out as, but 30 seconds or less, not bad. Not bad for starters. 22, okay, in the 20s. I think it's way faster on the build server than it is locally because it's actually doing a full npm install and then running the tests. All right. Did it say 37 or 57? Time flies when you're having fun, huh? Okay, makefile. All right, we're gonna speed this up a little bit. We're gonna add NodeBond. It's a monitoring tool that if you're doing like fast iterative development locally, you can just NodeBond your program and it watches all of your local files. And if you actually change one, it restarts the server for you. So I can make a change, it restarts the server. I can go hit, my manual test or whatever. All right, so let's do that. There's a dev dependency. And let's add our start script. I'm gonna kind of move this along a little faster because I really want to get to the Docker stuff. That's the more interesting. Where is that? That's in package JSON. So I'm gonna say start. There we go. So we say NodeBond, our server file, and here we're piping the output through Bunyan and giving Bunyan some parameters. So all that really is oh, I didn't do a make yet. Again, this feels very redundant because it is right now. But see, I wanted to type make immediately. Oh, yep. Maybe if you give it the option, you have to say run. It just means don't print the output, so it wouldn't do this. Well, what is the npm run silent start? What's that? I don't, it actually wouldn't run if there was a start file, but I should put it up there anyway. Needs. It doesn't have to. That just keeps it from echoing out. Oh. Oh wait, it doesn't like package JSON. Oh, that's weird. My autosave didn't work. Never had to do that before. Oh, because I was editing it at the same time npm install did it. Woohoo! Interesting. Well, how do I resolve that conflict? I've never seen this before. Where are you talking about? Oh. Oh yeah, sure enough. Look at that, they gave me the tools. So what do I want here? How do I say I'm cool with it? Oh yeah. Oh, new feature. Scary. There we go. All right, so Bunyan actually outputs JSON, the logger that we installed, but it has a command line utility that if you pipe its own output through the command line, it'll pretty format it for you. Makes it nice and handy. Okay, wow. That was painful. And let's add some curls for some handy dandy manual testing. So now if I do make start, is this for shell? Make. Oh, you're dead to me. I wanted to do that anyway to reset the ESLint. Make, oh, not you. Start. All right. Now let's go here. Say we're still in the same directory. Curl 200. See it yet? Curl 404. Boom. Doesn't write anything. Make. What did I call it? Health. Curl health. There we go. Manual testing complete. Okay. Is that everything for that step? Yes. Okay. Corey, what's my story? It's 9. I love that you're paying attention to that. Oh, I had a NodeBond. That was the important thing. Start. Okay. We're just gonna let the pipeline run. I believe it is gonna work. Okay, now we're gonna get in some kind of lengthy bits of configuration. But what we're doing here, so you remember how earlier we talked about Mocha being able to have plug-in reporters for how it wants to output all your unit test reports? Well, the kind of sucky thing is it only knows how to do one. And I really want the output of a couple of different ones because GitLab will ingest a JUnit formatted report, but I don't want to read that myself. I still want to look at my Mocha awesome nice HTML thing. So there's yet another reporter that's kind of like a T in a pipe. So you tell it to use this kind of T-based reporter, and you can configure as many reporters as you want, and it'll send the data to all of them. So that's what we're going to do. And this time we're actually going to do a merge request. By the way, I can't believe it's so easy to say merge request now because we've been doing it for so long, but that was my biggest beef with GitLab when we first started looking at them. Like, it's a pull request, damn it. Everybody calls it a pull request. But if you think about it, it makes more sense to call it a merge request because that's what you're asking for. Pull request, I think, came from the open source world where it's like, hey, pull my fork back, right? So anyway, I got over it. All right. Let's see. I really like the fact that everything that I want to do is all in the same place. You have one pane of glass to see everything associated with your deployment pipeline. I mean, GitHub is great. It does its job really well. I think they just came out with their new feature to try to start doing some CI/CD type things. GitLab was already mature in that space. I don't think it'll take them long to get there. So, I mean, GitLab has to stay on their toes if they want to stay ahead of that curve. But what are the other ones we looked at, Mike? I don't think Windows likes NodeBond very much. I shall stop using it. No, I think everything is consolidating. Everybody's kind of getting the same idea that GitLab had from the beginning. Is like, we need to provide like everything, and so you see. I mean, I think you're starting to see a lot of consolidation. Everybody's buying each other up. Yeah. So here's a slight deviation from how we used to work, and that is we used to create a branch locally, do all of our work, push the branch when we're done, and then go create a pull request. GitLab doesn't force you to, but their idea is, hey, why don't you go create your branch, immediately create your merge request, that we can have the conversation while it's going on. And you know, we've recently started working with a team of offshore developers, and it really helps to keep an eye on guys that you can't put your finger on, right? So every day we tell them, hey, as soon as you create your branch, make a merge request. And they have a thing that keeps it in, they call it whip status. So this will create, I just created a new JUnit branch, and the response when I pushed the branch up there gave me a URL to say, hey, just go to this URL to create your merge request. So that's what I'm doing, and it automatically prefixes it with whip. That way nobody says, hey, let me just go merge this really quick. I'm still working on it, but we can have the conversation in the merge request. Let's see. I do always like to check the box to delete the branch when the merge request is accepted. That can also happen at the time of pressing the merge button. All right, so now I have my merge request, AKA pull request. I mean, it looks super familiar, right? You can have a conversation. As I commit and push changes, they'll show up here, and I can see, you know, all the changed files and have that nice diff side-by-side view. Okay. All right, now I have some more npm installs, all the dev tools. I'm just going to copy paste this to get us through. All right, so now our test script is changing again because now we're going to use the Mocha multi-reporters, which is that reporter we just installed. It's that pipe T. And then we have options for that guy, and we're just going to give it a config file. So it's done. I won't try to edit it at the same time anymore. That didn't work out very nicely. So now I have my test. Let me edit that one more time. It's a little uglier, just because there's more stuff there and it's a longer name. So now we have to go, I imagine we'll need to go create that config file for all my test reporters, right? And there it is. Mocha reporters config.json. Okay, I can do that. Reporters config.json. And I made this file up in the middle of the night. Like, the file name is not any kind of standard. So what we've got here is we're saying, hey, I want to enable both the Mocha Awesome and the JUnit reporters. And here are the options for the Mocha Awesome reporter, and here's the option for JUnit. And most importantly, we're stuffing these into a reports folder, because what we're going to do is we're going to tell GitLab, hey, save that reports folder as an artifact from this job. Okay, and then what we're also going to say is, hey, that unit test XML is special. It's a JUnit file. You know how to deal with those. You can get some special sauce out of that. So here's my JUnit file that you can understand. All right. Make sure I don't miss a step here. All right, so back to the makefile. Yeah. So all we did, you know how I talked earlier about how makefiles had you could do dependencies. Well, what it's saying is, hey, when I run make test, go run ensure reports and make sure that my report folder exists before you crank that up, so it doesn't try to write out to a folder that isn't there. And I'm not going to clean that up right now. Okay, let's run it. I think it's enough to run now. Make test. So over on the left there, you should see it jump open with a reports folder. There it is. Okay, there's my new JUnit output. And here's my same kind of website that was there before. So now I have 3 reporters running, but one is actually just forking out to the other 2. So screw you, Mocha, and your 1 reporter limit. Okay, that's done. All right, now we're going to set up artifacts in our build step. And I'll copy it over there and we can talk about it when we get there. So the last step we usually do in these steps is, hey, let's go fix the pipeline to incorporate what we did into what's going on with our continuous delivery pipeline. So we have our build, and now we just throw on an artifacts property. This name isn't terribly important. It just introduces the fact that, hey, you can name the file. So it gives you a download button at the end of the job that says, hey, do you want to download your artifacts? And it will name it based on what you tell it. Otherwise, it gives it some weird, ugly name. Not that this is going to be a very pretty one. There are a crap ton of predefined environment variables that GitLab and many other CI tools will throw into your environment for you to tell you what's the job number, what's the pipeline ID, what's all these different things, right, that you can build things like file names out of. And that's what's going on right there. So we're saying our artifact is going to be the whole reports directory. And then there's a reports option that says, hey, I've got a JUnit report and it's this file. So now you should be able to do something with it. And I think that's all we have to do. Yep. All right, so let's commit. What's my ID? Oh, nobody caught it? Add JUnit reporter and reporter splitter. Yep. Okay, this time, let's do this. Closes number 6, not 36, number 6. So last time we were pushing directly to master. Now we're pushing to a merge request. So the lie that I told you last time about not auto moving the story to done until the pipeline was done, I think now this is the truth, where until you merge the pipeline, it won't move the story to done. We'll see. And I didn't do my whole check all the files thing, which will probably come back and bite me. All right. Let's go see actually, let's go see our board. Our story's still there. Let's go look at our merge request, actually. Because now this is where the action is. So you can see our pipeline running here. It shows that I did a commit. I can see the actual commit. If there's a lot of commits, I can see all of them. When you actually go do code reviews, you go right to the merge request page, and I go right to this changes file, and it shows you kind of the glommed together view of all the commits. Here are the actual changes that were made. I mean, this is just one commit, but if there were 10 commits, I don't want to look at each one individually. This shows the effect of all the changes. So we see that I added up the artifacts, and I did the dependency on ensure reports. See all the things that we changed. It's a nice place to review that. So back to my personal process, I do that locally in code, but while I'm building my commit, and then I depend on someone else to review my code pretty much in the same way once it's in the merge request. That's another build quality in thing, but it's more of a process than an automation. And pipeline complete. Now, it should show me something. It doesn't show me a lot, but you see now we have this test summary contain node change test results. If I had failed tests there, it would nag me about my failed tests. But here, it just says, hey, you're all good. You had no fails, or you had no changes since the last one. So that's what the special unit test XML JUnit thing does for us. You can also see that in the pipeline itself on the job. So if I go to the pipeline, click on my job, you can see now that I can either download my artifact, and there's my file name with job and or commit name or whatever that was, or I can also browse to that thing. There's my reports folder, there's my unit test, and bam. Now someone can come back later. You can put this in your change control, point change control to here and say, hey, look, here's proof that my tests all pass. I haven't tried it. I gotta be honest, I don't know. We would get Chip to answer, but he says he doesn't know technical stuff. He does bring delicious pizza. All right, where are we here? And time's ticking. Okay, now we need to merge, duh. Okay, let's go to our merge request. All right, so see how I still have this work in progress? So if I were working on a team, now that I'm happy with it, I can say, hey, resolve the work in progress status, or you can just edit it and take it off. And now it's ready to merge. And so now the pipeline will run yet again in the master branch. And we are confident that it's going to work, so I'm not going to go watch it. All right, back to the board. And ta-da, it moved our story for us because we said we said that commit closes that story. Once it was actually merged, it moved the story for us. Okay, one more thing to deal with unit tests, and then we can start Dockerization. All right, principles here: build quality in, continuous improvement. Code coverage is a weird subject. Just because code is covered doesn't mean there's good tests covering it, right? There could be really terrible tests that aren't really telling you anything. So code coverage by itself isn't the perfect metric, but it is a metric and it has value. So we have yet another dependency we need to install, and this is the Istanbul library, which is referred to by NYC. Go figure. And I just did that in my branch. Stop. Oh, good, you didn't do anything. Git checkout master, please. Full. Prune. Git branch. SD. JUnit. Okay, that Git BA is not standard. I've got some aliases. I really like the BA one. I don't even remember. It's like AVV or something like that. But I always just think of Mr. T. And it shows me all the branches, both local and remote, that I've got set up. Instead of just doing git branch. Right, so when I merged it, it did delete the branch on the remote. So origin deleted the branch, but I still had a reference to both the origin, which now doesn't exist anymore. And when I did git pull -- prune, that deleted the ones that don't exist on the remote anymore. And then I just deleted my local branch just to keep clean. And after doing all that, I forgot what the heck I'm doing. Okay. I'm in master, okay. So now we're installing our coverage tool. All right, one last time. We have to touch our test script. Yeah, I'm gonna do that. All right, this one's actually pretty easy. Bam. Now, the other thing is there's a whole lot of configuration that you can put in. And we'll go ahead and stick it in there. The nice thing about NYC/Istanbul is that you can just drop its configuration right in package.json. Don't need a separate file. These Dell keyboards are a pain in the keister because there's no home and end without doing weird shenanigans. All right, I'm not going to go into depth on this. What this is saying is, hey, look, I'm going to use the. All right, don't get confused here. These reporters are the coverage reporters, not the unit test reporters. These belong to NYC. So I'm gonna have another web page that's going to show me my coverage, and it's actually pretty cool. And the text one will show up in the output of the build. Report, see, we're putting our coverage report under the reports directory, which is already being saved as an artifact. The rest of this is just which files do I want to deal with. These watermarks in the output, it shows yellow and red, depending on if you're getting in the danger zone of what your coverage is. And these hard numbers are, hey, if you get below this threshold, I'm going to fail. So you can play with all those numbers, and they all have defaults. You don't have to set up any of those. All right, let's make tests now. All right, now you see this is the text reporter for coverage. And you see we have 100% coverage because I told it to exclude the stuff I don't have tests for. But those are files that you probably would do that to anyway because there's no testable code there. It's it's just some data, or it's just like the entry point to your program. All right, so here's a nice weird thing, and I don't know how other tools do this, but to suck in the actual coverage number, you give it a regular expression to go hunt in the output of the entire build where to find that coverage number. And then it sucks it in kind of like that JUnit report and it can paste that number in a couple of places. All right. So it changes, yep. So add coverage, and I'll make Corey cry. Oh, did I not put one up? All right, it's about to get serious. What you all came here for, and we have 30 minutes left for. Good old npm install. This is why I teetered on actually doing a Python program for this, because Python programs generally don't pull in as much crap. But I'm kind of a Python noob, and I didn't want to embarrass myself as much. Yeah, it's so long. All right, job succeeded. Now we get this tag, woohoo! And if we had actually done a branch for this, which we didn't, it shows up in the merge request that what your coverage number is. All right. Moving along, we're doing good. Okay, I had Dockerized the application as one big thing. And I was like, let's break this out a little bit. So what's interesting on their issue handling, epics is like a higher tier feature. So it's one of the highest paid tier feature gets epics. And I think because that's a feature that enterprises would use more than anybody else, and so that's where that goes. All right. So this goes back to what I was saying earlier about we want to be able to run the build. No, scratch that. What's going on here is that once we have a container, we're going to have two ways to execute the code. One is kind of naked, like we've been doing, and one is executing it in the container. And so what we're going to do is mess around with those lint and test scripts again. We're going to create a bash script that just does all of it. We're going to take our make test and call the bash script, because now I can call that from my local computer, and then we can just copy that script in, and we don't use make inside of the build of the container or the container itself. I don't know that we have a principle around that. It just confuses things if you do. So we only use make from the CI tool or locally, but once we're inside of the container, either during the build of the container inside the container, or the build of the image rather inside of that container, or once it's built, we don't have make files in there. I'm not saying you shouldn't, I'm saying that's how we do it. All right, here's another little thing that's we came up with this idea. I'm kind of proud of it, but maybe I shouldn't be. We have an bin folder. So we did a lot of bin folks. We around GameStop, we use node.js, .NET Core, and Python primarily, right? And so for all of our kind of automation scripts, we just had a bin folder in our projects, and that we'd stuff all of our shell scripts in there that do all the automation, and that was nice and clean until we started doing .NET Core. And .NET Core has its own bin folder that I think you generally get ignore. So that became a problem. And so I was thinking one weekend, there's an R bin and an S bin and a couple other kinds of prefixed bins. Why not an A bin for automation binaries in quotes? So that's what we've been using for almost a year now. So A bin is a thing at GameStop, and probably only at GameStop. Yeah, there you go. So we'll do that. We'll do make dir A bin. And we'll create a quick and dirty shell script. I didn't try to write all this code on the fly. what did I call it? Commit tests? Remember what I need to do? Wow. Okay. So this is basically what those two main jobs were doing. We're just going to do them in the shell script. And then we're going to create a new set executable rule in our makefile because we've been bitten by this many a time. And then we'll update our test rule in our makefile. To now use the script that we just wrote, and now we will also make sure that that's an executable, like we set the +X with a change mod before we try to execute it. Because who knows what actually ends up in Git, and then when it pulls down into the container, all bets are off, and it bit me last night, so it's going in. Yes. Yeah. Okay. So this was just a quick and dirty. Let's get something rearranged. So if I do make tests, so make test now does linting and then runs the unit test. So it's kind of a one-stop shop. The lint rule is still there. So if you pull in some code, you copy in something off of who knows what website, paste it into your code, and it's all ugly, you can just run make lint and fix all the problems. Okay, we're good. What are we going to call this? Get ready for Docker number 8. Is that what I said? Push. All right, boys and girls. Time has come. We're going to overhaul it all. We won't move it yet. Oh, I didn't tell it it was going to do that, did I? All right, Dockerize. I won't talk about the reasons we're running. All right, so this is the big story. Going from not Docker to Docker kind of upends a lot of the work that we've already done at this point. Not all of it. So of all the things that we've done here, there's one set of files that we haven't touched. That's the actual program, right? The program hasn't changed since lint when we had to fix all the line endings, right? All right, so and actually, maybe I should be ashamed to admit this, but I just learned how valuable the Docker ignore file is. I kind of just ignored it because I used to think that, hey, I never used the copy dot to dot anyway. I'm a little more careful than that. But what Docker ignore actually does for you is, when you do a Docker build, there's such a thing as the Docker context, right? And when you say Docker build whatever dot, you're saying my context is the current directory, right? And so it packages up that entire current directory, except what's in the Docker ignore file, and ships it off to the daemon, right? Well, that daemon, if you're on a Windows box, it lives on a virtual machine underneath your computer. I don't know where it lives. But, in for example, a Kubernetes GitLab runner, you're doing Docker and Docker between two containers in a pod in Kubernetes. And so you got the daemon in one container, and you got your kind of running container that's doing your scripts in the other container. And so you're having to ship all the files that are in your Docker context over to the daemon when you go to do the build. And that includes your .git folder, right? Which could grow over time, and who knows if it contains images, or don't put binaries in there, but it could contain binaries. It could be megs, right? So if you don't Docker ignore at least your .git folder, all that is getting chunked into the Docker context before that gets sent to the Docker daemon to go do the build. And just in these tiny little things that I was working on, I did an experiment, and it was about 4 times more data if I didn't Docker ignore certain things. And that's with very new, Git repositories and no images or anything like that. I mean, we're still talking about hundreds of Ks, but I mean, it was times 4. It was times 4. Okay, so here's what I've collected of things that I don't think Docker should care about in my particular case. So I'm going to create .docker ignore. Was that news to anybody besides me, by the way, about how that worked? Yeah. I would think it might behoove you to at least just start with the .git star. And that takes care of 80% of it. I would think. All right, anyway, there's my Docker ignore. That was a long-winded approach to that one tiny file. Okay, here's the monster, the Docker file. We went straight for, what's it called? Staged Docker build. So this is going to take some splaining. All right. So you'll see that I have 3 from statements here at the very beginning, one a little after the middle, and then one kind of right after that. So the final image is starting over from node 10 Alpine, whereas the second image is starting from build. And all it's doing is cleaning out all my dev dependencies that I don't want. But I didn't want to run this in this image, although I think the fact that it's a node 10 Alpine, I don't think it would have hurt me to do that. Anyway, what we have, kind of our standard thing around here is we use /app as our starting point in all of our containers. I don't think that's a hard and fast rule, that's just what we do. Again, we're using Alpine, so APK is our package manager for the operating system. We need certificates to call HTTPS, Python make, and Bash. We write all of our scripts in Bash. Most of the time, we probably don't have to. They probably would run just fine in Born. But on the odd occasion, we use kind of that was a double square bracket thing, and that's Bash only. So it's important, especially with Node, as you've seen how the npm install just takes forever, right? So package JSON is what drives those dependencies. And the way Docker layering works, I hope I'm not like boring everybody with this Docker stuff. But Docker layering is such that every line in this file creates a new layer that can be cached individually. And so once you kind of get settled in and you're just making changes to your code, I mean, we've been adding dependencies left and right, but that settles down and your package JSON file doesn't change very often after that. So you want to do that early. You want to put that early in your Docker file so that gets cached. And if it doesn't change very often, that layer can just be cached and you don't have to do that next step, which is npm install every time. Okay. So if we can limit the number of times we do npm install, we're golden. Then we need our shell scripts, our source code, and then all the little files from our root, such as our lint configuration and that big crappy Mocha reporters configuration. And we don't have to have this here, but this allows us to just execute the container and it'll run our commit tests, our lint and our test for us. Okay, because this is one big staged Docker build, if I do a Docker build with a target of build, I will just get this first part down to command that's highlighted, right? I'll just get that thing. And what that allows me to do now is I have a build ready, or what do I want to say this? It's a build image, right? It's got all my scripts in it. It's got all my dev dependencies. I can run all the unit testing, whatever I want to do. So I can dump all of my scripts in that guy and use that to execute any of my tests that we will one day write, like our integration tests and our functional acceptance tests. Those can all run from that container calling against another container. And then we just need the Docker base container to run our CI. That was a little long-winded. But anyway, this last part here is our actual pristine application, right? So it only needs teeny, which was another new thing for me. I've been frustrated before. And if you know developers, if you haven't seen this before, have you ever run a container where you're running Node as PID1, right? And let's say it's a, some kind of a web service or something, and you can't control C that thing, it won't die. It's because Node doesn't know how to run on PID1. It can't accept signals for some reason. And so there's this little, it's called teeny, T-I-N-I maybe, I don't know. But it's a proxy that will sit in PID1 and accept those signals and send them on to whatever else app is running after it. So now I can run a Node container with Node as PID1 or as the entry point, and I can control C that bad boy. Anyway, by the way, our entry point is teeny, and the command that gets passed to that is node and calling our actual application. All right. Now another big change is happening in the makefile, and you guys might want to spend some time on this later if you're interested, and I'd be happy to chat with you about it after. But I think we're running low on time. I really want to get this thing deployed. Makefile. So now let's go up to the very beginning. Now we have a build, and this will build our application and build our actual artifact, which is the image. And so let's try it. Make build. Now let me explain a little bit of what's going on here. You'll see that the build rule has Docker build twice. The first time it's building with a target of build. It's building that first section, that first stage. And then we actually do a Docker run on that build image that we just created, and we run our commit tests inside that container that has all of our dependencies and stuff in it. Then the next thing, and also what we do, and this is kind of important in our case because we need those reports to come out of there, right? So we mount, or we bind mount our local drive reports folder into the container when we execute that script. It dumps all of the output into reports, and then we have it locally. And then finally, we build the application image, the final image that's going to run the application. And that thing is done. So now we have the image locally, but how do we run it? Well, of course, we have a run make rule, so that we don't have to type that nasty Docker command every time we want to run the container locally. All this is doing, standard Docker run. We usually do the -rm so that it deletes the container when it's done and we don't have to clean it up later. We're passing the node env as development. I don't know if that actually does anything, but it's a good practice. Then which image are we running? And then we're going to pipe the output of that to Bunyan, right? So just like we had the start, the make start, this is doing the exact same thing, but through the container now, right? So I just did the build. Let's do a make run. What does it not like? Path must be a string. We'll deal with it later. Don't have time. So that's a fail. All right, so now let's get into the CI YAML. It's going to work on Linux. So let's add these to the top. So before we were actually in our CI YAML file, we're running a node image, right? No longer. Oh no. Now, oh, that's so ugly. So the YAML parser does not like this new default tag. I think it's a kind of a new thing. Before you would just put these things out globally, but that's going to be deprecated. So use the default tag if you're going to default these things. So my image now is the Docker image, And now I'm specifying a service of the Docker and Docker tagged Docker image, right? So here's what's going on. I've got a Kubernetes cluster, and I've got a pod that's running. That's the GitLab runner. This thing talks to us, says, "Hey, I got a job for you." He says, "Okay." He creates a pod. In that pod are two containers. One is the Docker container, which has the Docker CLI. The other is the Docker in Docker container, which is hosting the Docker daemon, right? So because they're in the same pod, they can talk to each other on localhost. They have the same IP. And so the Docker and Docker container, he's doing all the heavy lifting, and he's storing the caches, and he's storing all the images and doing the work. And your main guy is just calling that guy. And that's going to cause us a problem here in a minute, because when we make build locally, we're caching all those layers. Well, what happens to my pod when my job finishes? It's gone, along with all my cached layers, which I now have to pull again, and I have no caching for my npm install. Okay, but we'll fix that. Okay, but first, the other thing is, I don't want to go into too much detail, but you specify these variables so that your Docker container can talk to the Docker and Docker guy. This tells it the port. See, it's on localhost, and that's the Docker daemon port. This has something to do with the file system. Now, our build step has pretty much been overhauled, and it looks really ugly, but it's not that bad. And we're just going to copy paste the whole thing over top of it. So this stuff at the end didn't change. We still have our artifacts and our coverage. We're still building on our Kubernetes runner. So image is the CI registry image. So we're actually using the Docker registry that's built into GitLab, and each project has its own. So this variable says, hey, if you're going to store an image in this repository, here it is. Like, here's the path to it. Right? We're still in so build and release tags. So that's what's tagged. That's what's being tagged when I build the first half of that Docker container or that Docker file. It's getting tagged with build. Okay, and when I build the whole thing, that thing is being tagged with candidate. All right, and that's when I run make build. That's the thing we did locally. That's going to do the exact same thing we did locally, and it's going to create two images. One is a build image. One is a candidate image. This other stuff is just like logging into Docker. All right, now we have a build and a candidate, but those aren't going to do us a whole lot of good. We need those things to be long-lived, so that if they make it past candidate status, then we need to be able to deploy them and not have some ephemeral tag that keeps jumping between different images, right? And so all we're going to do is we're going to tag our candidate image with the commit SHA. So the actual full-blown, I don't know how long that string is, get SHA of the current commit is going to be the tag, the ID of the image that we're about to push. So we'll do that with both the release and the build. Basically, we're saving a copy or saving a tag that we can get to later and not lose it. It's a bookmark for it, right? So that's really all that's going on here. That's all. Okay. So there's one more thing we're going to do, and that is 10 minutes. That's not a hard stop for me. It might be for my throat. So we created a new stage now. So we finally have two stages in our pipeline, right? So we have these images, and they're just basically, hey, these images were built against this commit hash. So this is the one for that commit hash. It's like an artifact, really, right? It's the artifact for that commit. But long term, if we want to go further than that, so only on the master branch. So if we, for example, we did this on an MR on a feature branch, and then we merged that in. If it passed all its tests, then we want to go ahead and apply the latest tag to it, right? Because it's passed, it's the official latest image. We still have a copy, or we still have the tag that's the actual commit SHA, the commit hash, but there's also a tag pointing to the same image that's latest. And when the next one comes through, there'll be a new SHA, and then we'll point latest to that new one, right? But the commit SHAs stay in there. They stay in the history. So that's what's going on here. Okay. All right, we see we're hitting the public stage, and this only happens on a master branch. Well, a couple of special things to notice here. We're only doing Docker commands. We don't care about what's in the code anymore. So we tell it, hey, I really don't care that you pull down all the files with Git, so just don't. And that saves us a little time, saves us a little energy. And then here on dependencies, we also don't care about artifacts. So you specify your dependencies, and by default, you get all the artifacts from all the stages from before. If we say, hey, I have no dependencies, I don't need any of your artifacts. So now we're not getting our code from Git, and we're also not getting artifacts that were built, like all those test reports. All right, all we're really doing, we're gonna pull the commit SHA that was just built, and we're gonna tag it with latest. We're gonna push it back as latest. That's all that's going on there. We only do that on the master. I think that's it for that step. And we're gonna go ahead and push this directly into master and watch the magic. Dockerize. Now it's time to cue the Jeopardy music. Did you see when I ran it locally how long it took to build? We were doing other things, but it was running in the background. It wasn't terribly speedy, well, by the standards we've been looking at, right? It was not 20 seconds. So let's take a look and see what's going on. So now you see that our pipeline has 2 stages. It knows what they are. It knows at the very beginning what it wants to do. So we'll take a look at the output of that puppy. Running our make build. All right. Can you guys see that? This looks like pretty Dockery stuff going on. There's our APK adding our operating system dependencies. There it is. npm install. Doing the work. Actually, that was pretty quick. Well, 18, almost 19 seconds to do npm install. Could be a lot worse. All right. So now we built the image. Now we used the image to create a container, and we executed our commit stage inside the container that has all of our dependencies in it. And now we're going through and we're going to build the release image. But to build the release image, now we have to go back through the whole Docker file again, right? But now, because we did this locally, now see all that first layer is cached. We didn't have to do anything special there because it just built it, and we're still running in that same pod. And so that second Docker and Docker container has all those Docker layers cached, and it's picking them up. So pushed our commit SHA, and that should be pretty close to done. So if we go over here to publish, that guy's running now, and he's already done. Publish doesn't take any time at all. just running a couple of Docker commands. All right. What do we notice here? Before, our passing tests were 30, 40 seconds at the most. Now 2.5 minutes. Kind of sucks. All right. So we're always going to get 2.5 minutes if we change something early in the Docker. If we add a new package or something, it changes that package and it invalidates that layer of the Docker cache, right? Even if we had it cached locally. Now we don't even have that, so it's going to take that every time. So let's try to fix that really quick. Call that done. Oh, we'll call that done. All right, we're almost to time, guys. You're free to stay. You're not going to hurt my feelings if you leave. I kind of want to leave myself. All right. Okay, so now we're going to look at the cache from feature of Docker build. It's a feature that I saw a while back, and I really didn't understand when I might want to use it, because every time I do a Docker build, all my stuff's already cached. What the heck? I don't need to do that, right? But here's our special case, right? We had our pod, we built it, now it's gone. Now we push the next commit, and nothing in those lower things changed, right? We changed some other file that's way down the line. So it would be really nice if we could reuse all those layers without having to do npm install again and having to figure out all that stuff, right? So it does cost a little bit. We have to go now pull those images that we want to use as a cache, and then we just tell Docker build, hey, I want to use those for a cache, please. Right, so let's go back to our build make rule. And this is effectively the same thing we had before, except now we have this cache from option. So we're basically caching from the exact same thing that we're rebuilding. And then down here, this is a more interesting one. In the final build, we're caching from both the build and the last release. Because remember, in our Docker file, the bottom part, the application part of the release, doesn't say from the previous stage, it says from Alpine. Because I don't want any of that other crap that you did in those previous stages. I'm starting fresh. And so my cache on release tag won't have any of those layers in it. And so I can specify, hey, the first part of my Docker file was built as this other image. Use that for a cache, and use the last thing I built of myself as a cache. And so it can take layers from both of those. All right. Back to the makefile. Where's my build? You guys keep me honest. Oh, let me do something dumb. Okay, so now we have our cache from statements. And now, in our script, in our GitLab CI, right before we do all those shenanigans, before we do make build, and I don't have a home key, we're actually going to go pull those images that we're going to use for a cache. And then when make build runs, now it has those images available. Okay, so the only files we changed here were the makefile and the GitLab CI YAML file. So those caches, so we've previously built those images now, and now let's try it. Push it in. And it's true. It's true. Come on, go. here's the one that matters. So we're doing the pull first. So that does cost us a little bit in data and time. Then we're going to pull the other one. Here we go. Using cache, using cache, using cache. Bam, done. Using cache all the way down. Now, the only thing it doesn't have cached, I don't know if you saw it. I don't even know where it is. But the part where there it is right there. Nobody can cache that middle stage where I do my prune, right? And maybe if I think I might be able to move that just into the main container and it would cache that too. But that cost me 6 seconds. It adds up. Okay, so that's done in 48 seconds. Cut it in half, more than half. I think it's worth it. All right. There is a caching feature. The same idea. You can cache paths across pipeline runs. You have to do special setup if you're running your own cluster, and I wanted to do the whole Docker stage build anyway, so I have no idea how it all works. So, but yes, that feature does exist. Okay. So this step we're not even going to do because it's already done. So we'll package up Helm really quick. Really quick. All right, so we're going to use Helm to deploy. We're past the build. Time to do some damn deployment. And we are going to copy paste our way to victory. You're just all kinds of hosed up. Am I still on master? Yes. All right, so now we have our chart folder structure. And let's create our chart YAML file. This is a super minimal file. I don't want that guy. It goes here. YAML with an A. Does that actually matter? I always put it, but I've never tried not to. And then, so this is our values file. And the way we're doing our Helm install here, we're not going to publish our Helm chart. We're going to package it, and it's going to be an artifact in our one pipeline. We're going to use it one time and throw it away. Okay. We will have arguments about this in the coming weeks about whether we should actually publish the chart. Lots of fun arguments. Anyway, let's save our values file. YAML, paste in. These values make a whole lot of sense once you actually see the templates. I will let you review this at your leisure. It's just filling in all the blanks. We could probably spend a whole another time talking about deploying with Helm. All right, so I have a few templates. The big one is the deployment YAML. This is all the things. So let's go to templates, create deployment YAML, paste in my template. Just a quick overview. We get a lot of fun labels here, doesn't matter. Where are we? Here we go, the container. It's going to use values Docker registry, which is coming from CI, from GitLab. Values Docker image, also coming from GitLab. Values Docker tag, also coming from GitLab. And this is, it's setting up our port as 80 or 3000 or whatever it's going to be. Service. So this is going to expose our container from, or it'll actually load balance if we have multiple of these guys running, and expose within the cluster kind of a unified front to our service. Call it service. Yeah. I think we're just trying to prove that it's going to work at this point. Ingress is something that I still am getting a grip on, but basically it allows us to get into our resources from outside, and it requires an ingress controller to be running. This is ingress. All right. All right, now we got to package this thing. More scripts. Ensure version variables. Sure. SH. Boom. Yep, I see you. Line feeds. Is there another thing I need to do? So now we need a packaging script. The deployment is where really a lot of the scripts come into play, because deployment is where you have to interact with the real world. So pack chart, another A bin, pack chart. So this is doing a helm init, a helm lint, more quality going on there. And then we're helm packaging. The chart version is pretending to be dynamic. I've actually got it hard coded somewhere. The app version is going to be the actual tag that you're going to run, the tag of the Docker image. And then this is going to be the name of the chart. So we're going to package this up. It'll package it as a TGZ file. All right, now of course we need a make rule. Make all the things. Pack chart. There's make. Notice our list of files has gotten awfully big lately, huh? All right. So it's also making sure that the thing's executable, and we're good to go. Calls the pack chart. Oh, you want to see if it works? So all this is going to do is do the packaging. We're not deploying anything yet. We should just make a, there it is, TGZ file. That's our Helm chart. All right, now let's update the pipeline so that the pipeline can make a Helm chart. So now we're going to have our first parallel build, or our first parallel job, and it's going to be in the build stage. We're basically just going to call that make command that we just called. Should probably go in a different place, but for time's sake, it's in the build stage. It does, order doesn't matter of these, it's just what makes sense to you when you're looking at it. We're using a Helm repo that's Alpine. We don't care about previous artifacts. Then we're setting up our tag. And then we're calling make pack chart. And we're saying that now this job has an artifact that's the actual package, right? So we packaged it in this job, but we need some other job to deploy this thing. So we'll create the package, and then we'll let someone else deploy it, but we have to save it as an artifact. All right. I'm trusting that you guys are watching this and make sure I don't do something stupid. Package Helm chart. We're almost there. One more. One more. All right, so we'll talk about this one. There's nothing to do here. This talks about all the setup that you have to do to actually do a real deployment. It talks about setting up your GKE cluster. It talks about setting up your ingress controller, both of which can be done right from GitLab and it works out of the box. I wouldn't recommend it for production use, but it's fine for playing with this kind of stuff. And then these are the environment variables that you need to set up. These two will be set up by the script itself, but we're actually setting these as CI/CD variables at the group level. So even above our project level, everything under the Gibbles group now has access to these things. All right. Let's see if our pipeline worked. No, it's still going. Come on, you can do it. Our package worked though. So if we go look at our pipeline from kind of the top level view now, you'll see that we have two parallel jobs. If two jobs are in the same stage, they will run in parallel. And then that feeds into, and basically, there's a new change that just came out that makes me a liar about this. But generally, the next stage's jobs won't start until all the previous jobs have completed successfully. But there's a new feature that lets you do weird things. Okay, it's done. So remember that Helm chart was packaged for that pipeline, and now it's an artifact in the job in that pipeline, but no other pipeline can access it. Each pipeline builds its own chart, which feels kind of weird, which is why you might want to publish your Helm chart to an external repository. But again, that's what we'll be arguing in the next week. We talked about that, and I did it yesterday. So here goes. I'm not sure I'm ready for this. All right. Of course, there's a deploy.sh. Where is it? Okay. Okay. Nothing crazy going on. This is there so that you can run this locally as well as in the CI server. We don't want to change any logic, but we will change variables on the fly depending on where you are. So really all that's happening here, we're setting up the variables and then we call helm upgrade -- install, which basically says install it if it ain't there, upgrade it if it is. And we're overriding certain variables. We're giving it the release name that was passed in, and we're using the the artifact, the chart artifact that we created in the pack chart that will have happened before the stage that we're on now. Wait, did I fix that? I did. And of course we need to make roll. Boy, man, it looks easy from there. You guys want to try it locally? You feel lucky? Okay, I'm still connected. You can see I practiced. All right, make deploy. That's what I'm saying. I should be able to do this from my box as well as on the CI server, and it should work the same. Boom, it's done. Status, no, helm ls first. So there it is, hello. Right. Hello demo, yeah, that's right. Helm status, hello demo local. It's using my username to suffix that. That way, if multiple people are working, it'll say local your username and you get your own. Seems to be working. So what if I say curl? Will that work? I think it will. Curl hello demo local sgivens.dshang.com/songs/a number. Bam. We're not done. We're not done yet. We got to make GitLab do it. Okay, so this is a special worker only script that's kind of it's doing that same thing, right? It's doing the authentication to the server and Helm and getting everything set up. Like I have mine locally that I did myself. We have to set it up for the cloud provider and for the CI tool. So this is using gcloud. It's doing the whole login to your service account, and that's part of all those variables that we sent in. It's a painful mess. And I linked an article somewhere in these instructions that made a lot of sense. So let me fix it. And let's create a prod stage because we don't need no stinking integration tests. Where's my file? Getting loopy. Prod. I'm going to production because we unit tested it. All right, here's a new job called deploy. All right, you see it does a bunch of crap, only runs on master. Make deploy, that's what we did locally. Same thing, same thing. All right, I think that's all it wants us to do. Boom, boom, boom. All right. Boy, sucker. All right, what's our job? You're falling down on me, man. 12. What was this? 12. Push. All right. This is it, ladies and gentlemen. I turned out a lot longer than I planned. It's public. Yep, it's public. Cool. I can't promise how long I'll leave the cluster running. Yeah, I'll leave the project up for sure. It is on GitLab, so there's the URL right at the top. Oh, it didn't make that any bigger, did it? It's gitlab.com/GIBBLES. And there's only a handful of things in there, and they're all variations on this thing. There's Hello API, which is actually a more complicated version of this that still doesn't do any testing past unit testing, but it does releases based on tags. So latest comes off of the tag, and candidate comes off of master, or edge comes off of master, candidate comes off of a non-master build. There we go. Thanks for sticking around, guys.